Your company needs to implement auto-scaling for a web application running on Amazon EC2. The application should automatically scale based on CPU utilization and should handle traffic spikes during peak hours. Options: A. Use EC2 auto-scaling with a target CPU utilization policy. B. Use Amazon Elastic Load Balancer, ELB, with multiple EC2 instances. C. Use Amazon Lambda with auto-scaling policies. D. Use EC2 auto-scaling with a fixed instance count. Correct answer: A. Use EC2 auto-scaling with a target CPU utilization policy. Explanation: Option A allows EC2 instances to automatically scale in or out based on a target CPU utilization policy, which ensures the application can handle varying levels of traffic without manual intervention. Why not other options? Option B: while ELB helps distribute traffic, it does not automatically scale EC2 instances based on CPU utilization. Autoscaling is needed for dynamic scaling. Option C: Lambda is designed for serverless applications, not for managing EC2 instances. EC2 autoscaling is better suited for this scenario. Option D: a fixed instance count doesn't provide flexibility to scale based on actual demand, which is essential for handling traffic spikes effectively. You need to securely transfer data between two AWS regions. The data is highly sensitive, and you must ensure it is encrypted both in transit and at rest. Options: A. Use Amazon S3 with cross-region replication and enable encryption at rest and in transit. B. Use AWS Direct Connect with encryption enabled. C. Use Amazon EC2 instances to manually transfer data between regions. D. Use AWS Snowball for transferring large datasets between regions. Correct answer: A. Use Amazon S3 with cross-region replication and enable encryption at rest and in transit. Explanation: Option A provides a secure and automated way to transfer data across regions with cross-region replication in S3, ensuring both encryption at rest and in transit. Why not other options? Option B: AWS Direct Connect provides a private connection between on-premises infrastructure and AWS, but encryption in transit requires additional configuration and is not specifically designed for transferring data between regions. Option C: EC2 instances require manual intervention, which is less scalable and introduces complexity compared to using S3 cross-region replication. Option D: AWS Snowball is ideal for physical transfers of large datasets, but is not optimized for real-time or ongoing data transfers between regions. You need to implement high availability for a multi-tier application with a web front-end, application layer, and database back-end. The application must remain operational even if an availability zone, AZ, goes down. Options: A. Deploy EC2 instances in multiple availability zones with Elastic Load Balancer and RDS Multi-AZ for database redundancy. B. Deploy EC2 instances in a single availability zone with an auto-scaling group and an RDS instance. C. Deploy EC2 instances in multiple availability zones and use Amazon DynamoDB for the database layer. D. Deploy EC2 instances in multiple availability zones with S3 for the database. Correct answer: A. Deploy EC2 instances in multiple availability zones with Elastic Load Balancer and RDS Multi-AZ for database redundancy. Explanation: Option A provides high availability by distributing EC2 instances across multiple availability zones. The Elastic Load Balancer ensures traffic distribution, and RDS Multi-AZ guarantees database redundancy and failover capabilities. Why not other options? Option B: a single availability zone creates a single point of failure. RDS Multi-AZ should be used with multiple availability zones for high availability. Option C: DynamoDB is a great NoSQL database, but for relational database needs, RDS is more appropriate for a multi-tier application architecture. Option D: S3 is an object storage service and is not designed for transactional or relational database storage. RDS is the right choice for database redundancy. Your development team needs to set up multiple environments for testing and staging purposes. The environments should be cost-effective and should only run when necessary, automatically shutting down when not in use. Options: A. Use EC2 instances with auto-scaling and schedule the instances to stop during off hours. B. Use EC2 spot instances to run development environments. C. Use Amazon Lightsail for all development environments. D. Use AWS Elastic Beanstalk with auto-scaling for all environments. Correct answer: B. Use EC2 spot instances to run development environments. Explanation: Option B provides a highly cost-effective solution for development environments. EC2 spot instances allow you to take advantage of unused EC2 capacity at a significantly lower cost than on-demand instances. Why not other options? Option A: While scheduling EC2 instances to stop during off hours can reduce costs, spot instances are more cost-effective than on-demand instances for non-critical workloads. Option C: Amazon Lightsail is ideal for simple workloads, but may not offer the flexibility required for complex development environments. Option D: Elastic Beanstalk is a PaaS solution that automatically handles application deployment, but it may not be as cost-effective as using spot instances for development environments. You need to grant a specific set of users secure access to an S3 bucket, but you want to ensure they cannot access any other resources in your AWS environment. Options: A. Use an S3 bucket policy to allow access based on specific IAM user conditions. B. Use IAM roles to provide access to the S3 bucket. C. Use AWS KMS to encrypt the S3 bucket and restrict access to encrypted objects. D. Use Amazon CloudFront with signed URLs to restrict access to the S3 bucket. Correct answer: A. Use an S3 bucket policy to allow access based on specific IAM user conditions. Explanation: Option A allows you to control access to the S3 bucket using fine-grained permissions based on IAM users, ensuring that only the specified users can access the resources. Why not other options? Option B: IAM roles are used to grant permissions to entities like EC2 instances or Lambda functions, not directly to specific users. While IAM roles can be used in conjunction with bucket policies, Option A is a more direct solution. Option C: AWS KMS encryption ensures data is protected, but it doesn't directly address access control based on IAM users or conditions. Bucket policies are more appropriate for controlling access. Option D: CloudFront with signed URLs is used to control access to S3 objects via distribution, but bucket policies provide more straightforward access control for a specific set of IAM users. Your company runs a global e-commerce website hosted in the AWS cloud. The website needs to provide low-latency access to users from different geographic locations, including Asia, Europe, and North America. You want to optimize content delivery and minimize latency for all users. Options: A. Use Amazon S3 with CloudFront for caching and content delivery. B. Use Amazon EC2 instances in each region and configure cross-region replication for the data. C. Use AWS Global Accelerator to direct users to the closest available region and deploy the web application across multiple regions. D. Use Elastic Load Balancer with multiple availability zones in one region. Correct answer: C. Use AWS Global Accelerator to direct users to the closest available region and deploy the web application across multiple regions. Explanation: Option C uses AWS Global Accelerator, which optimizes the path to your application by directing users to the nearest healthy AWS endpoint, ensuring low-latency access for global traffic. Why not other options? Option A: While S3 and CloudFront can deliver content effectively for static assets, Global Accelerator is better for dynamic content and ensuring the lowest latency by routing traffic to the closest region. Option B: Managing EC2 instances in each region can increase complexity and cost. Cross-region replication is typically used for data but doesn't optimize for low-latency access globally. Option D: ELB with multiple AZs in one region does not offer a global solution. It is more suitable for high availability within a specific region, not for optimizing global traffic. Your company needs to implement a disaster recovery (DR) solution for its application that runs in an AWS region. The solution should ensure business continuity in the event of a regional failure, with minimal data loss and downtime. Options: A. Use Amazon RDS multi-AZ deployment and implement an S3 bucket for cross-region replication. B. Use Amazon EC2 instances in an auto-scaling group with S3 backup for data storage. C. Use Amazon Route 53 with health checks to redirect traffic to a secondary region in the event of failure. D. Use AWS Elastic Beanstalk with multiple environments in different regions. Correct answer: A. Use Amazon RDS multi-AZ deployment and implement an S3 bucket for cross-region replication. Explanation: Option A offers a comprehensive solution. RDS multi-AZ ensures database failover in case of regional failure, and cross-region S3 replication ensures that critical data is available in a backup region. Why not other options? Option B, EC2 auto-scaling and S3 backup don't provide the database-level resilience needed for disaster recovery. Multi-AZ RDS is more appropriate for database continuity. Option C, Route 53 can help with failover, but without multi-AZ or cross-region replication for databases and other critical data, it won't ensure full business continuity. Option D, Elastic Beanstalk with multiple environments may help with scaling but doesn't provide the database replication and backup strategy necessary for a true disaster recovery solution. You need to deploy a serverless application that processes data when events occur. The application must scale automatically and only incur costs when processing events. Additionally, the application should integrate with other AWS services to store data and handle notifications. Options: A. Use AWS Lambda with API Gateway, Amazon S3, and Amazon SNS. B. Use AWS Elastic Beanstalk with an auto-scaling group and an S3 bucket. C. Use EC2 instances with an auto-scaling group and S3 for data storage. D. Use Amazon ECS with Fargate and Amazon SNS for notifications. Correct answer: A. Use AWS Lambda with API Gateway, Amazon S3, and Amazon SNS. Explanation: Option A provides a fully serverless solution. AWS Lambda automatically scales based on events, API Gateway handles the HTTP requests, S3 stores the data, and SNS manages notifications. This is a cost-effective and scalable architecture. Why not other options? Option B, Elastic Beanstalk is not fully serverless. It involves EC2 instances and requires management of scaling and infrastructure. Lambda is more suitable for event-driven serverless applications. Option C, EC2 instances are not needed for a serverless application. Lambda is more efficient and cost-effective for event-driven workloads. Option D, Amazon ECS with Fargate is serverless for containerized applications, but Lambda is simpler and more cost-effective for processing events in real time. You have a web application running in a private subnet within a VPC. You need to securely allow users from the internet to access the application without exposing the application servers directly to the public internet. Options: A. Use an application load balancer, ALB, with SSL termination and configure a security group to allow access. B. Use a VPN connection to allow users to access the application. C. Use a bastion host to provide secure access to the private subnet. D. Use AWS Direct Connect to provide access to the application. Correct answer: A. Use an application load balancer, ALB, with SSL termination and configure a security group to allow access. Explanation: Option A allows secure access to your application through an ALB, with SSL termination to ensure encrypted communication. The ALB can route traffic to private subnets, ensuring security without exposing the application servers. Why not other options? Option B, a VPN connection is not necessary for allowing general internet access to your application. It's more suited for private, secure communication between on-premises networks and AWS. Option C, a bastion host is used to manage access to instances in a private subnet but is not ideal for direct application access. ALB is better suited for routing user traffic. Option D, AWS Direct Connect is a private connection between on-premises and AWS, typically used for low-latency, high-bandwidth applications. It's not designed for public access to a web application. Your company needs to set up a data lake to store structured and unstructured data from various sources. The solution should be scalable, cost-effective, and allow analysts to query the data without requiring complex ETL processes. Options: A. Use Amazon S3 for storage, AWS Glue for ETL, and Amazon Athena for querying data. B. Use Amazon RDS for storing structured data and Amazon Redshift for unstructured data. C. Use Amazon DynamoDB for storing structured data and Amazon S3 for unstructured data. D. Use Amazon EFS for data storage and Amazon EMR for processing data. Correct answer: A. Use Amazon S3 for storage, AWS Glue for ETL, and Amazon Athena for querying data. Explanation: Option A provides a scalable and cost-effective solution for a data lake. Amazon S3 stores data, AWS Glue helps in ETL tasks, and Amazon Athena allows for querying data directly in S3 without the need for complex ETL processes. Why not other options? Option B. RDS and Redshift are not designed for unstructured data storage, and their pricing model is not suitable for storing large amounts of raw data. Option C. DynamoDB is a NoSQL database, but it's not intended for storing large, unstructured data. S3 is more suitable for unstructured data, while Glue and Athena are the better tools for ETL and querying. Option D. EFS is more suitable for shared file storage, but S3 is a better choice for a data lake. EMR is used for big data processing, not for building a data lake.